Answer is 8. Answer to this one should be 7. If you can get it before the bell goes off. Answer was 18. Here's the warm-up. Answer is x minus 6. Answer should be x minus 5. Last one. Alright, the answer on this one should have been x plus 5. Here are the A papers from Friday. Sexton, Rayburn, Collett, Johnson, Howard with the ooh girl across the top. Finally he gets an A plus. And Applegate B, Applegate M, Davis, Lewis, Huey, Jones, Smith. Alright, time for the test review. Number 1 should have been x squared plus 9x plus 42, remainder 16. On this problem number 1, it was right on the key, except here on the sheet, it's missing the 2, so it should be remainder 216. Number 2 is x, remainder negative 2. 3 is 4x to the third minus 30x squared plus 235x minus 1873, remainder 14,981. 4 is 3x minus 11, remainder 34. 5 is x to the third minus 5x squared plus 16x minus 35, remainder 72. 6 is 6x minus 28, remainder 164. 7 is negative 2x squared minus 3x minus 1, remainder 4. 8 is x plus 2, remainder 2. 9 is 5x minus 20, remainder 110. 10 is x squared plus 4x plus 23, remainder 135. The extra credit, A was 38, B is 11, C is negative 13, D is 11, E is negative 67. Homework. Bring it up here if you have your work shown for all problems on notebook paper. 17 out of 22 have their homework, and that translates into a percent of 77. If you have credit for your homework, pick a number from 1 to 20 for a chance at 20 free points. Anybody have 13? We have Dietrich, all right, and Lewis and Pemberton. Well, that'll help out, 20 extra points. Okay, here come the answers, I think. Can't remember. Nope. Before the answers, here's a fast multiple choice. Block letter only. The answer on this one should be A. Now for the homework answers. There are only 5 of them. I'll read them off, and then we'll go back and check anything you have questions about. Number 1, 3x to the fourth minus 10x to the third plus 17x squared minus 32x plus 63, remainder negative 120. Number 2, x to the third minus 5x squared minus 7x minus 3, remainder 7. Number 3 is negative x squared minus 7x minus 27, remainder negative 143. Now I made a small mistake here. That should be a negative 147. So we'll just draw an arrow there. Number 4, 6x plus 26, remainder 119. And number 5, negative 5x minus 7, remainder negative 126. Did I say 126?
Yeah.
Oh, it is negative 26, isn't it?
Yeah.
I don't know why I said 126. Here's a quick review. Just say the answer out loud.
Well, that's the fifth.
Nope.
Oh, 24x to the fifth.
24x to the 5th is right.
5.
5.
3x to the 13th. 20. I did the top number. 4x. 6x to the 4th. 2x to the 3rd. X to the 4th. X to the 6th. Yeah. 6x to the 4th. 7x to the 3rd. Negative 12x.
A lottery for everybody, 1 to 10. The winning number is 5. Alright, the objective for this time. Factor by grouping is what we're going to do. This is APR B3. Identify zeros of polynomials when suitable factorizations are available, and use the zeros to construct a rough graph of the function defined by the polynomial. We can't do any of this until we have practiced factoring. Remember, by now we've done this. We've done the difference of two squares and the sum of two squares, set in reverse. And we've also just accomplished basic factoring like 2x squared plus 2x, and you can factor out an x from each of those. So just basic, and we've done the sum of two squares from the imaginary numbers. We've done the difference of two squares. We have factored by just factoring out two numbers that multiply to give you the back end and then add to give you the middle for a quadratic equation. So what you're going to do is add one more thing to that, and that's factor by grouping. Here's a short pretest, and this doesn't count against you, but you do have to bring it up and drop it off, and this lets me know how many people can factor this out before we go through this unit. If you factor by grouping, you're going to do just that. You're going to come up with two groups. So there's no one right way to do it. Just try to look at your two items. Sometimes it helps to just start with the first two. So if I group those together, ax squared plus 2x to the 3rd, make that a group. Notice I have a minus sign here. Make that minus, but then change the sign of everything after that. So instead of minus 9a, I have a positive 9a and then a plus 18x. Because when you go back and distribute this out, this would change it back to these, so it doesn't change the value. So now try to factor out anything if possible. Looks to me like you can take out an x squared from each of these. So x squared, and then you'd have to multiply that by a and 2x. Over here you could take out a 9 from each of them. That would leave you with an a and then plus 2x. So now look what we have here. When you come up with two quantities that are identical, that means you just write that down once. And then the other two you combine together, x squared minus 9. Now that would ordinarily be the final answer, except what's x squared minus 9? No, I mean what kind of expression is it? You have, what is this? Starts with an S. Q.
Square.
It's a square. And is this a square too? And what's this? Minus sign. What's the answer to a minus problem?
It would be
Starts with D. I. F. Difference of two what?
squares.
Squares. So you can still factor that one piece out. And instead of x squared minus 9, it's just x plus 3, x minus 3. And this would be the final answer. If you put this on a test, then you would be missing some points. Here's example 1. So 4ab plus 12ax minus 7b minus 21. When you first look at one of these problems, see if you can find items in common between two different terms. For example, give me two terms that have something in common in here. 4ab and 12ax. What do they have in common? They both have a's and, yeah, multiples of 4. That's right. And so we could try it that way and use what's left over in its own group. Or you could do it another way. Is there anything that 12ax minus 21x have in common?
They're both multiples of, oh, never mind.
Yeah, they're both multiples of 3, and they both have a what? An x. So you could try these two together first if you want to. There's no one right way to start it. So instead of using what Davis told me to start with, which is these two, I'm going to use these two just to prove the point that you can start anywhere. You can give it a try. So if I use this and this, I would have 12ax minus 21x in my first group. And then what's left over is this and this. And since I'm using the 4ab first, it's positive, put a plus sign in the middle. If your first term of the next group is negative, you've got to take out that negative sign from each item in there. But we haven't arrived at one of those yet, except in the pretest problem. So 4ab and minus 7b. All right, so in the first group, what do I have that's in common here between this and this? I can take out a 3x, right. 3 will go into both, and so will x. 3x times what is 12ax? 4a, not x, because it'd be an x squared. And then 3x times what is minus 21x? Minus 7, yeah. So now when we go over here, there's nothing to take out of either of those. You can't take a b out of 4a.
There's a b in there.
Yeah, there's a b in there, but we have to find something that both of these have in common.
4ab. It's 4ab. And you just have 4a.
Oh, it's 4ab? Oh, my fault. Yeah, it helps if I copy the problem right. There we go. So you're right, you can take out an a. You could, or a b, I'm sorry. You can take a b out. There we go. You can take a b out and be left with 4a minus 7. There we go. I just didn't write the b down. I wondered what was missing. But 4a minus 7 matches up with 4a minus 7. And if that's the case, you can just write down 4a minus 7 in its own quantity, and in the second one you will fill it in with what these terms are here. 3x plus b. Here's example 2. 4ab plus 16ax plus 9b plus 36x. Anybody give me two terms that I could start with?
16ax and 36x.
Okay, we'll start there. 16ax and then 36x. That's what we're putting together. So naturally the other ones would have to be 4ab and then 9b. Hopefully I've copied it right this time. So in the first one, What can I take out of both of those terms?
16x.
Can't take out a 16 from 36.
No, 4. I was thinking
Take out a 4. And what else?
4.
An x. 4x times what would give me 16ax?
4a.
4a is right. And then 4x times what is 36x? 9. What can I take out of 4ab and 9b?
B.
Yeah, just a b. So I'm left with 4a plus 9. These two are the same quantity, so it worked out. 4a plus 9, and in the second one would be 4x plus b. Give this a try. If you're going to group these by the first two, you would have 16xy plus 18x. And then over on this side, if you group these two together, this is just like the pretest problem. If you have a negative sign on your first term, then you put that negative sign in between your quantities and change the sign of each one inside. Like that. And when you do that, you can take out a 2x over here and be left with an 8y plus 9. And then on this side, you can take out a 9 and be left with an 8y plus 9. So 2x minus 9 in one set and 8y plus 9 in the other.
Did it right.
I got my X's